Hello everyone. Today I am going to start the third lecture on second modulo, that is Fourier series, third semester engineering mathematics. Course is Transform Calculus, Fourier series and Numerical Technique. Code is 18MAT31. Already I have explained 3 examples on Fourier series, means to obtain the Fourier series for the given function. In this lecture I will explain the 4th example. If you want the explanation of first example, go through the first lecture, and for second and third example, go through the second lecture. And today we will discuss the 4th example. Find the Fourier series in open interval minus pi to pi to represent the following function: f of x is equal to x square x minus x square. We have to obtain the Fourier series for the given function f of x, where f of x is x minus x square. Let the period of f of x is equal to pi minus of minus pi, which is equal to 2 pi, and the Fourier series of a period 2 pi is given by f of x is equal to a0 by 2 plus summation n running from 1 to infinity an cos nx plus summation n running from 1 to infinity bn sin nx, and name this series as equation 1. And we know that these constants a0, an, bn are where a0 is equal to 1 by pi integration from minus pi to pi, because our function lies between minus pi to pi. Therefore, integration from minus pi to pi f of x dx, an is equal to 1 by pi integration from minus pi to pi f of x cos nx dx, and bn is equal to 1 by pi integration from minus pi to pi f of x sin nx dx. After that we have to find this constant. For that, first one is, now a0 is equal to 1 by pi integration from minus pi to pi f of x dx. We know that f of x is x minus x square. Therefore, it is 1 by pi integration from minus pi to pi x minus x square dx. Now, we have to integrate this x minus x square. Therefore, a0 is equal to 1 by pi as it is. Integration of x is x square by 2 minus integration of x square is x cube by 3. Limits from minus pi to pi. Then, keep 1 by pi as it is. First apply the upper limit, then lower limit. When we apply upper limit and lower limit for this first term, that is x square by 2, we will get pi square by 2 minus pi square by 2, minus of this minus as it is here. Next, applying upper limit and lower limit for this second term, that is x cube by 3, we get x cube by 3 minus of minus pi cube by 3, this is pi cube by 3 minus of pi cube by 3. We get this first term will cancel, because pi square by 2 minus pi square by 2 is 0. Then minus of pi cube by 3, minus into minus plus, it will be pi cube by 3, it will be minus 2 pi cube by 3. Already we have here 1 by pi, therefore it is 2 minus 2 pi cube by 3 pi. Then this denominator pi can cancel with this one of the numerator pi. It will be minus 2 pi square by 3. And in our Fourier series we have a0 by 2, so that we have to find the value of a0 by 2. For that, take this 2 in this side, we get n. Therefore, a0 by 2 is equal to minus pi square by 3. First term is over. Next is, we have to find the second coefficient, that is an. Now, an is equal to 1 by pi integration from minus pi to pi f of x cos nx. we know that f of x is x minus x square. Substituting f of x as x minus x square, then an is equal to 1 by pi, limits from minus pi to pi, x minus x square cos nx dx. Write once again, an is equal to 1 by pi integration from minus pi to pi x minus x square cos nx dx. Now we have to integrate this one. To integrate this one, we have to use the Bernoulli's rule. According to that, consider this term x minus x square as a differentiating part and cos nx as a integrating part. You get an is equal to, keep 1 by pi as it is. Now we have to keep differentiating part as it is and integrate this cos nx. We get sin nx divided by n minus, now differentiate this x minus x square, we get 1 minus 2x, because differentiation of x is 1, differentiation of x square is 2x, therefore it is 1 minus 2x into, again integrate this sin nx by n, here 1 by n is constant, keep as it is, just you have to integrate the sin nx, then it will be minus cos nx divided by n into n is n square, plus again you have to differentiate this 1 minus 2x. We know that differentiation of 1 is 0 and differentiation of this 2x is 2. Here we have negative sign, therefore it is plus minus 2 into, again keep 1 by n square as it is and integrate this cos nx, we get minus n square minus sin nx divided by n square into n means it is n cube, limits from minus pi to pi. Next we have to apply the limits. N is equal to, see here we have to apply the limits as pi. We know that sin n pi value is 0, therefore this first term and last term will be 0. We get only middle term, so that we have to apply this limits to middle term only, because this first term and last term will be 0 when we apply this limits, because sin n pi value is 0. Here 1 by n square is constant, take outside the limit. N is equal to 1 by pi n square into 1 minus 2x cos nx, limits from minus pi to pi. N is equal to 1 divided by pi n square, apply the upper limit, 1 minus 2 pi cos n pi, minus, we have to apply the lower limit, 1 minus 2 into minus pi, it is a plus, therefore it is 1 plus 2 pi sin n pi, because cos of minus theta is cos theta. Then n is equal to minus 4 by n square into cos n pi, because when you split this term, cos n pi minus 2 pi cos n pi minus cos n pi plus 2 pi cos n pi you will get, then plus cos n pi minus cos n pi get cancelled, you get 4 pi cos n pi, and then that pi and this denominator pi get cancelled each other, you get only minus 4 by n square into cos n pi. We know that cos pi value is minus 1, here we have cos n pi, therefore it is minus 1 divided by n square into minus 1 raised to n, therefore an is equal to 4 into minus 1 raised to n plus 1, because here already we have minus negative sign here, this minus 1 it will be 4 into minus 1 raised to n plus 1 divided by n square. Now we have to find the Bn. Next is Bn is equal to 1 by pi integration from minus pi to pi f of x sin nx dx. F of x is what? X minus x square. Again to find the integration of this, we have to use the Bernoulli's rule. Here also you have to consider x minus x square as a differentiating part and sin nx as integrating part. Keep differentiating part as it is, x minus x square Here bn is equal to 1 by pi, keep as it is, then x minus x square as it is. Integration of sin nx is minus cos nx divided by n, minus differentiate this x minus x square, we will get 1 minus 2x, then again integrate this one, we get minus sin nx divided by n into n is n square, plus differentiate this 1 minus 2x, differentiation of 1 is 0 and differentiation of 2x is 2, therefore it is minus 2 into cos nx divided by n cube, because integration of sin nx is minus cos nx, minus minus get cancelled, therefore it is only plus cos nx divided by n cube, limits from minus pi to pi. Then bn is equal to 1 by pi as it is. Apply the limits. See here, the middle term will be 0 because cos n pi value is 0. Therefore, bn is equal to 1 by pi. In this term, in this first term, take minus 1 by n common, constant it is. Take outside the limits. Then apply upper limit pi minus pi square into cos n pi minus lower limit is minus pi square, minus pi whole square is pi square, it is, therefore it is minus pi square, cos of minus theta is cos theta, therefore it is cos n pi minus, then from this last term take minus 2 by n square, here plus into minus is minus, 2 by n cube is constant, then apply upper limit and lower limit for this cos nx, we get cos n pi minus cos n pi. See here, cos n pi minus cos n pi, it will be 0, therefore after simplification we get bn is equal to minus 1 by pi n into 2 pi cos n pi is equal to minus 2 by n into minus 1 raised to n, because this pi cancel with this denominator pi and cos n pi value is minus 1 raised to n. Therefore, bn value is bn is equal to 2 by n into minus 1 raised to n plus 1. Here we have negative sign, it will be minus 1 raised to n plus 1. Therefore, bn is equal to 2 by n minus 1 raised to n plus 1. Then the Fourier series is given by substitute all the values on the coefficients a0 by 2 value, an value and bn value in equation 1. We get f of x is equal to x minus x square, f of x is x minus x square, which is equal to minus pi square by 3 plus 4 into summation n running from 1 to infinity minus 1 raised to n plus 1 divided by n square into cos nx. Here 2 is in that an, 4 is constant, therefore I am taking 4 in for the summation. Here 2 is constant, therefore plus 2 into summation n running from 1 to infinity minus 1 raised to n plus 1 divided by n square into sin n x. This is the Fourier series for the given function f of x, where f of x is x minus x square. Next, fifth example. An alternating current after passing through a rectifier has the form I is equal to I naught sin theta. For I, theta lies between 0 and pi, means 0 is less than, theta is less than or equal to pi, and I value is 0 for pi is less than, theta is less than or equal to 2 pi. Here our given function have two sub functions, means I is equal to I sin theta when theta 0 is less than, theta is less than or equal to pi, and I is equal to 0 for pi is less than, theta is less than or equal to pi, where I naught is the maximum current. Express I as a Fourier series in 0, 2 pi. We have to find the Fourier series for the given function. Here function is f of x is equal to I, where I is equal to I naught sin theta when 0 is less than, theta is less than or equal to pi, and I is 0 for pi is less than, theta is less than or equal to pi. Solution. The Fourier series of a period 2 pi is given by f of theta is equal to, here our variable is theta, so that we have to take in place of x, we have to take theta. Therefore, f of theta is equal to a naught by 2 plus summation n running from 1 to infinity a n cos n theta plus summation n running from 1 to infinity b n sin n theta. Name this is equation 1. Now, we have to find the Fourier coefficients by using Euler's formulae for the interval 0, 2 pi, where a naught is equal to 1 by pi integration from 0 to 2 pi f of theta d theta, because here our interval is from 0 to 2 pi, therefore it is integration from 0 to 2 pi f of theta into d theta, and an is equal to 1 by pi integration from 0 to 2 pi f of theta cos n theta d theta, and bn is equal to 1 by pi integration from 0 to 2 pi f of theta sin theta d theta. See here, your given function have two sub functions, and when limit 0 to pi it is I naught sin theta, when it is pi to 2 pi this is 0, I value is 0, therefore the whole integral value is 0. Therefore, each of the above integrals after splitting into two integrals in the range 0, pi, pi, 2 pi, and substituting for f of t will be a naught is equal to I naught by pi, where I naught is constant, therefore take outside the integration, I naught by pi integration from 0 to pi sin n theta d theta. When we take the next term it will be 0, because the I value is 0 for the second function when the limits is from pi to 2 pi. Therefore, similarly an is equal to I naught by 2 integration from 0 to pi sin n theta cos n theta into cos n theta d theta, and bn is equal to I naught by pi integration from 0 to pi sin n theta into sin n theta d theta. Sorry, it is only sin theta, not sin n theta, it is also sin theta. Wait, see, now it is correct. Our given function I is equal to I naught sin theta only, not sin n theta, therefore it is also sin theta, this is sin theta, this is sin theta, this is cos n theta, sin n theta d theta. Now we have to find the a naught first. A naught is equal to I naught by pi integration from 0 to pi sin n theta d theta, and a naught is equal to a naught by pi. We know that integration of sin theta is minus cos theta, limits from 0 to pi, therefore a naught is equal to a naught I naught by, here it is minus, take outside, minus I naught by pi, apply the limits, upper limit minus lower limit, therefore it is cos pi minus cos 0. We know that cos pi value is minus 1 and cos 0 value is 1, therefore it is minus 1 minus 1, it will be minus 2, minus into minus plus, therefore it is a naught is equal to 2 I naught by pi. Therefore a naught by 2, in our Fourier series we have a naught by 2 term, therefore we have to find what is a naught by 2. A naught by 2 is equal to I naught by pi. Next we have to find the coefficient an. Then an is equal to I naught by pi integration from 0 to pi sin theta cos n theta d theta. To find the integration of this one, we have to use the cos a sin a cos b formula. Using sin a cos b is equal to, we know that sin a cos b is half into sin a plus b plus sin a minus b. We have a naught an is equal to I naught by pi integration from 0 to pi 1 by 2 into sin a is theta, b is n theta, therefore sin theta plus n theta plus sin theta minus n theta d theta. 1 by 2 is constant, take outside the integration, n is equal to I naught by 2 pi integration from 0 to pi, and take theta, in this 2 term theta is common, take outside that, sin of 1 plus n theta plus sin of 1 minus n into theta d theta. Now an is equal to I naught by 2 pi integration from 0 to pi. I will write this n plus 1 as 1 plus n as n plus 1, therefore it is sin n plus 1 theta. Now for this term I have to write this sin 1 minus n as sin n minus 1. We know that sin of minus theta is minus sin theta, therefore it is minus sin n minus 1 into theta d theta. Now integrate this one. An is equal to I naught by 2 pi. Integration of sin theta is cos theta minus cos theta, therefore it is a minus cos n plus 1 into theta divided by n plus 1 minus integration of minus sin theta is a minus cos theta, therefore it is minus cos n minus 1 into theta divided by n minus 1, limits from 0 to pi. Minus into minus plus will be, it will be plus, therefore an is equal to I naught by 2 pi minus cos n plus 1 theta divided by n plus 1 plus cos of n minus 1 into theta divided by n minus 1, limits from 0 to pi where n is not equal to 1. This result is for n is not equal to 1. When n is equal to 1, it will be infinity, so that we have to take, it must be, n must be not equal to 1. Now apply the limits. N is equal to I naught by 2 pi minus 1 by n plus 1 cos n plus 1 pi minus cos 0 plus 1 divided by n minus 1 into upper limit cos n minus 1 pi minus cos 0. Means first you have to take minus 1 divided by n plus 1 constant outside the limits, then apply upper limit and lower limit for this first term and take 1 divided by minus 1 outside and apply the upper limit and lower limit for the second term. Then we know that cos 0 value is 1 and cos k pi means cos n pi or cos k pi is equal to minus 1 raised to k, and rearranging the above terms we get an is equal to I naught by 2 pi minus 1 divided by n plus 1 as it is, cos of n plus 1 pi is minus 1 raised to n plus 1 minus cos 0 value is 1 plus again 1 by n minus 1 as it is, cos of n plus n minus 1 pi is minus 1 raised to n minus 1 minus cos 0 value is 1. Now an is equal to I naught by 2 pi. Take first the terms having minus 1 raised to something terms first, then it will be minus 1 divided by n plus 1 into minus 1 raised to n plus 1. It will be, then take this one plus 1 divided by n minus 1 into n minus 1 raised to n plus 1 plus, now the remaining term minus 1 divided by n plus 1 into minus 1, it will be plus, therefore 1 divided by n plus 1 minus 1 into 1 divided by n minus 1 is minus 1 divided by n minus 1. Take the LCM and simplify this term. An is equal to I naught by 2 pi, then minus 1 raised to n. In this 2 term take minus 1 raised to n common, then it will be, here we have minus 1 and here we have minus 1 raised to 1, minus 1 raised to 1, minus 1 raised to 1. I am taking already minus 1 raised to n common, minus 1 raised to 1 minus 1 raised to 1 will be minus 1 raised to 1 plus 1, therefore it is minus 1 raised to 2 means minus 1 square divided by n plus 1 plus, then it is, we have here only minus 1, 1 raised to 1 minus 1 raised to 1 will be minus 1 raised to 1 divided by n minus 1 plus, take LCM and simplify, we get minus 2 divided by n plus 1 into n minus 1. We know that n plus 1 into n minus 1 is n square minus 1. On using the formula a plus b into a minus b is a square minus b square. Then an is equal to I naught by 2 pi minus 1 raised to n, 1 divided by n plus 1, minus 1 square is 1, 1 divided by n plus 1 minus 1 divided by n minus 1 plus minus 2 divided by n square minus 1. This term will be n square minus 1. Again you have to simplify these two terms, take LCM and simplify. We get a, now an is equal to I naught by 2 pi minus 1 raised to n, 1 divided by n plus 1 minus 1 divided by n minus 1 plus minus 2 divided by n square minus 1. On taking LCM and simplification, we get minus 1 raised to n minus 2 divided by n square minus 1 plus minus 2 divided by n square minus 1. Then in this 2 term, minus 2 is common, take outside. An is equal to minus 2 by I naught by 2 pi minus 1 raised to n 1 divided by n square minus 1 plus 1 divided by n square minus 1. Then take n square minus 1 common in these 2 terms, and then 2 get cancelled here. Minus I naught by pi into n square minus 1 into 1 plus, here it is, when we take this 1 divided by n square minus 1 common, it will be plus 1 plus minus 1 raised to n, where n is not equal to 1. When we have the term like this, where n is not equal to 1, we have to find the first term, that is a1. Now we shall find an when n is equal to 1, that is to find a1. An is equal to I naught by pi integration from 0 to pi sin theta cos n theta d theta. When n is equal to 1, it will be a1 is equal to I naught by pi integration from 0 to pi sin theta cos theta d theta. Then we have to multiply and divide 2 to this term. We get 2 into sin theta cos theta divided by 2 into d theta. We know that sin 2 theta is 2 sin theta into cos theta. Therefore, this 2 sin theta cos theta can be written as sin 2 theta, and take this 1 by 2 outside the integration. We get a1 is equal to I naught by 2 pi integration from 0 to pi sin 2 theta d theta. We know that integration of sin 2 theta is minus cos 2 theta divided by 2, limits from 0 to pi. Next, a1 is equal to I naught by 2 pi minus cos 2 theta divided by 2, limits from 0 to pi, minus I naught divided by 4 pi. 2 into 2, it is 4. Then apply limits. Cos 2 pi minus cos 0. Cos 2 pi value is 1, 1 minus 1 is 0. Therefore, a1 value is 0, and an is equal to minus I naught by pi into n square minus 1 into 1 plus minus 1 raised to n, for n is not equal to 1. Now we have to find the bn. Bn is equal to I naught by pi integration from 0 to pi sin theta sin n theta d theta. Here we are using the formula sin A sin B formula. We know that sin A sin B is equal to half into cos A minus B minus cos A plus B. Here A value is theta, B value is n theta. Bn is equal to I naught by pi integration from 0 to pi 1 by 2 into cos theta minus sin theta minus cos theta plus sin theta into d theta. Now Bn is equal to I naught by pi integration from 0 to pi half into cos theta minus sin theta minus n theta minus cos theta plus n theta d theta. Take this constant outside and take theta common in these 2 terms. Here also same. We get cos of n minus 1 theta minus cos of n plus 1 into theta. Now I have to write this as n minus 1 minus n as n minus 1. We know that cos of minus theta is cos theta. You see here cos of minus theta is cos theta. Using that result, we get Bn is equal to I naught by 2 pi integration from 0 to pi cos of n minus 1 theta minus cos of n plus 1 into theta d theta. Now integrate this one. Bn is equal to I naught by 2 pi sin of n minus 1 into theta divided by n minus 1 minus integration of this one sin of n plus 1 theta n plus 1 into theta divided by n plus 1, limits from 0 to pi. Since sin pi value is 0 and sin 0 value is 0, this whole term will be 0, because when we apply upper limit it is 0, and when we apply lower limit then also it is 0, because sin 0 value is also 0 and sin pi value is also 0. Therefore, Bn value is 0 where n is not equal to 1. Then we have to find, here n is not equal to 1, we have to find the Bn value, B1 value. Now we shall find Bn when n is equal to 1, that is to find B1. We have B1 is equal to I naught by pi integration from 0 to pi sin theta sin n theta d theta. Putting n is equal to 1, B1 is equal to I naught by pi. This is not B1, Bn it will be 0 to pi sin theta d theta. We know that sin theta is a sin square theta. We have to apply the result, that is the sin square theta is equal to half into 1 minus cos theta. Therefore B1 can be written as B1 is equal to I naught by pi 0 to pi half into 1 minus cos theta d theta. Then we have to integrate this one, take 1 by 2 outside this integration because this is constant. I naught by 2 pi integration from 0 to pi 1 minus cos 2 theta d theta. Then B1 is equal to I naught by pi integration from 0 to pi 1 minus cos 2 theta d theta. We know that integration of 1 is a theta minus integration of cos 2 theta is a sin 2 theta divided by 2, limits from 0 to pi. Then B1 is equal to I naught by 2 pi. Here the second term will be 0 when we apply both upper limit and lower limit, because sin pi value is 0, sin 0 value is 0, then it will be pi minus 0, which is equal to this pi cancel with this denominator pi, only B1 is equal to I naught by 2. Therefore B1 is equal to I naught by 2 and Bn is equal to 0 when n is not equal to 1. Then thus by substituting these values in 1, the required Fourier series will be I is equal to f of theta is equal to I naught by pi plus summation n running from 2 to infinity, because here n is not equal to 1 and also we are finding the Bn value. Here we have to take the limits from 2 to infinity, therefore summation n running from 2 to infinity I naught divided by pi into n square minus 1 into 1 plus minus 1 raised to n cos n theta. Here a1 value is 0, then plus here Bn value is 0, only we have to specify the B1, that is a naught by 2 sin n theta. This is the Fourier series for the given function I, when I is equal to I naught sin theta, where theta lies between 0 to pi and this is 0 when theta lies between pi to 2 pi. This is the Fourier series.